So in problem number 1, we're asked to look at a particular function and determine the end behavior. So I prefer to actually do the end behavior myself, and then to look back here and go, yes, I agree with this, or I disagree with this. For your test, you will not be given end behavior, and you're not going to be asked to determine is it true or false. You're actually going to write it out. For your quiz, it's a true or false statement. There are multiple versions of the quiz, just so you know. There's 6 versions. But for the actual test, you are going to be given something like this and just told to identify the end behavior. So there's a couple different ways to do that. We talked about this in class just the other day, and that is if you look here and we first start by identifying the degree. And you feel free to look back in your notes if that helps you right now. This degree, which is the highest exponent, is odd. So think back to your notes where I had you write even on one side, odd on the other side, and we said, okay, those are positive. There's even negative, odd positive, odd negative. Can you raise your hand if you remember what I'm referring to in your notes? Okay, so this is an example of odd. Now, is it odd positive or odd negative? It is odd positive because the number in front, which is a hidden 1, is a positive number. So I'm looking for odd positive. This is odd positive. Now, how do I take that and then write it in terms of end behavior? So it looks something like this. So I know that this is the option, odd positive. As I go to the far left, the function is going down. As I go to the far right, the function is going up. So just like the first problem we did, you're going to look at this function and determine the end behavior. To find this answer, we need to look at all the exponents, and the degree means the highest exponent. So this is odd, so I have odd, and now I look in front. This is odd negative. Sometimes people are caught up on the even odd, and they're like, it's odd, odd, right? Odd and even is only determined by the exponent, and then the number in front we're going to say is either positive or negative. So I'm looking for odd negative, and when I look back in my notes, I know odd negative looks like this. On the right it goes down, and on the left it goes up. So how do I use this to fill out this form? As I go to the far left, it's headed up. As I go to the far right, it's in the next problem, you're going to be provided a graph, and you're going to be told what type of a function is. So we're going to be told in this problem that we are working with a cubic function. So a cubic function means that the degree would be 3. That means the roots have to add up to 3 roots. So I'm going to make 3 lines representing the 3 type of roots. And then the type of roots are either going to be real or imaginary or a combination of both. The first thing you're going to do is you're going to look at the x-axis, and you're going to identify all of the x-intercepts. Every x-intercept is an example of a real root. So here, I don't need to say, oh, it occurs at -3, at +2, and at +7. They're not asking for the location. They're asking for the type of root. So this is real because it's x-intercept. So one of them is real, another one is real, another one is real. So I have, in this case, 3 reals and 0 imaginary. In this problem, you again are provided with a cubic function, and you're asked to identify the type of roots. How many of each type? So because it's cubic, I know that there will be 3. And so the first thing I do is I look for the x-intercepts. How many x-intercepts does this function have? 1. So one of them is real. Well, if you don't see any other x-intercepts, that means the other x-intercepts, so they have to add up to 3, have to be imaginary. So this would have 1 real, and it would have 2 imaginary. This is an example of a quartic function. Just really quick, here are the functions you need to know. You need to know that linear means degree 1. I'm going to abbreviate. Quadratic is degree 2. Cubic is degree 3. Quartic is degree 4. You don't have to memorize anything past that. And you're thinking, why do I have to memorize that? Because when it tells us this is an example of a quartic function, I know I need to have 4 roots. And they may be a combination of both real and imaginary. So how do I determine that? Well, first I determine the number of real, and then anything left is imaginary. So I go down the line here, and I'm looking at the x-axis. Not the y-axis. There's 1, 2. So 1, 2. 2 of those are real. Well, what are the other remaining? The other remaining have to be imaginary, and they have to add up to 4 because quartic is degree 4. So here we have an example of a function that has 2 real and 2 imaginary. Another example of quartic on your own. Please go ahead and identify the number of each type of root. So the 2 types of roots are real and imaginary. How many total of each type? Knowing that this is an example of a quartic. So in this example, I look at the x-axis because they're always going to identify the reals first. There's no reals. Well, if there's no reals, then every single one of them has to be imaginary. So first identify the real. Anything that's left over is going to be imaginary. So we're going to ask to find the quotient. That means whatever comes first is going to go inside. And if you're like me, you're not naturally very neat, take your time here so that we can see, in this case, 4 separate columns and x plus 2 out front. Now, personally, I think it's helpful wherever you see an x, if you don't see a number in front, throw a 1 in front. So I've got a 1, got a number, got a number, got a number. Okay, we're good. A common problem students face in a previous hour when I went over these problems, they said, I don't know where to start. So you start by underlining what's out front and what's out front and the inside and the outside. And I'm going to use this as like my little scratch area over here, okay? So I'm going to ask myself, 1 times what equals 4? 1 times 4 equals 4. So I'm going to put a little 4 over here. And x, how many more x's do I need to get to x to the third? I have 1, I need 2 more. Now I want to make sure I did this right, so I'm going to check. 1 times 4 is 4, good. X and 2 more x is x to the third. So I agree with this answer. And now I have to decide which one of the 4 columns does it go into. Well, because it's an x squared, it goes into the x squared column. Once you determine what goes on top, we're going to multiply. And you multiply the outside first and then the secondary. So if there would be 3 things that would go to the front, the middle, the last. In this case, we only have 2. So front and then last. 4 times 1 is 4. I have a total of 3 x's. 4 times 2 is positive 8, and I have a total of 2 x's. Don't forget to change the sign of everything on the second row. So it was positive, and I make them negative. Positive 4x cubed and negative 4x cubed, they cancel out. You know you're doing it right when your first ones cancel out every time. If these would not cancel out, you want to go back and look back at what you chose as the number up above. Positive 12 and negative 8, they're different signs I subtract, keeping the sign of the larger number. Then I bring down the next number and I start the whole process over again. I underline what's out front and I underline what's out front below. And I ask myself, 1 times what is 4? 1 times what is 4? Okay, I think that's 4. I need a total of 2 x's and I only have 1, so I need 1 more x. And I want to make sure I did this right, so let's check. 1 times 4 is 4. 2x is x squared. Okay, I like that answer. So I'm going to put a positive 4x up above. Don't forget to include the sign. Multiplying, 4 times 1 is 4, and we have 2 x's. 4 times 2 is 8 with 1x. If you happen to miss the day when we went over this, this probably is extremely confusing for you. There is a video I can send you. In the second line, I'm going to change the signs. And then I'm going to combine. Again, I always want when I combine for the first 2 to cancel out. I bring down negative 17x and a positive 10. I'm using the very last number, which means I'm on the last time of doing this. Underline the first, underline the first. 1 times what is negative 17? 1 times negative 17. I need 1x, I already have it, so I can attach a negative 17 up above. Multiplying to get negative 17x minus 34, changing the signs, and combining. Now, this alone, I did all the work right, but it says find the quotient. So I did the work, but now I need to properly write it. So how do you properly write this? So I have 4x squared plus 4x minus 17. All that's good, but I didn't get it didn't go in evenly. I have a remainder. So the remainder is going to be plus 44 over the expression out front. This is the final answer. The next question is this. Is x plus 2 a factor of 4x cubed plus 12x squared minus 9x plus 10. Is this a factor? Well, we actually just tested it. So if x plus 2 was a factor, if it was a factor, then we'd get an answer of 0. We tested it, and the answer is no, it's not a factor. Not a factor. And how do you know? You know because the remainder is not 0. Not a factor, we know, because the remainder is not 0. What else does that mean? Remember, it lies to us on the inside. So what else does that mean? It means x equals negative 2 is not an x-intercept. So to complete this problem, I'm putting the x minus 3 out front and the x squared minus 8x plus 15 on the inside. Underline the first in each group, and I'm going, okay, adding a 1 there because I didn't see a 1. 1 times what is 1? That's a 1. How many more x's do I need? I need 1 more x. So I know 1x is what I want, and I can just verify that. 1 times 1 is 1. X and x is x squared. Okay, great. So 1x I'm going to put in the right column, the column that has only x's, and then I multiply. 1 times 1 is 1. X times x squared minus 3x. 1 times negative 3 with an x. Make sure to change the sign of everything on the second row. And then we combine down. Underline and underline. 1 times what is negative 5? Negative 5. I need 1x, and I already have it, so I can put a negative 5 above the column that does not have any x's. Multiplying to get negative 5x and positive 15. Again, and then change the sign of everything on the second row. And combining, and I end up with 0. So how to make sure I don't see your cell phone. If I see your cell phone, I will take it, even if you're done. So this is my final answer. Would you get it wrong if you put a remainder of 0 over x minus 3? It wouldn't be wrong, but you don't. This isn't necessary when the remainder is 0. So this is my answer. And now the question is x minus 3 a factor? Is x minus 3 a factor of this? Is x minus 3 a factor of this? The answer is? Yes. And how do you know that? Because the remainder is 0. What else does this mean? Remember, it lies to you. It means that x equals negative 3 is an x-intercept if you graph this. So if you graph this, we know x equals negative 3 is an x-intercept. Being a factor relates to being an x-intercept when it lies to you. I meant to put a positive 3. This has to be, it lies to us. It has to be opposite. Thank you for pointing that out, Max. So here's the next one. I'm not going to write all the words out, but here we go. So I want you to find the quotient of this. X minus 2 up front, 3x cubed plus 5x squared minus 12x minus 20. So sorry. Find the quotient and then determine, is x minus 2 a factor? What does it tell us? This tells us, because the remainder is 0, that x minus 2 is a factor of this function because the remainder is 0. It also tells us, it lies to us here, tells us that we do have an x-intercept of 2. We do have an x-intercept of 2 within this function. we're going to practice rounding. I want you really quickly to round each one of these to the nearest tenth. Nearest tenth. Without any explanation. We do that because it's a common misunderstanding. You go one place after. This is the tenth. This is the hundredth. This is the thousandth. So tenth, I go here, and this is what I look at. And I want to know, is the answer 19.3 or should I round up? The answer is round up. 19.4 approximation when you round to the nearest tenth. So I'm looking right here because I'm only going to the tenth, and I'm going, is it 2.4 or do I round up? 2.4. Is it 3.1 or do I round up? 3.1. Is it 5.8 or do I round up? 5.8. Now, why did we just go over all of that? Because there was a lot of difficulty with this particular problem. Give me a second to zoom in here for you. There we go. I want you to go to Desmos. I'll be doing this at the exact same time. And I want you to graph these, and I want you to, when you find where they intersect, I want you to round that ordered pair to the nearest tenth. Okay, I'm going to give you 2 minutes to do this. Go ahead, please. These are the 3 ordered pairs that describe where the 2 functions intersect. And I did take each of the intersections as it prompted us to, and I round them to the nearest. The profit of a small business in thousands of dollars, that's a key factor here, can be modeled by the following equation where T represents the number of years since 1980, and that wants us to specifically find where is this on the graph and then interpret it in terms of the time and profit. So let's talk about profit. Your profit means after you take in money for a specific amount of time that you're looking at, and then you are going to subtract things like your operating costs, like how much does it cost to rent the space you're using, or to purchase electricity, or the cost of supplies, or the cost to hire people. After you take out all those additional costs, what do you have remaining? Sometimes it's a positive number, sometimes it's a negative number. Now, before we do this problem, if I said in the year 1982...
transition to period 4.
If I said the year 1982, what T value would that be? It says we start. So we start. This is the very beginning. We start at 1980. So what T value can we assume is 1982?
17.
If 1980 is the very beginning, it's your zero value, what can we assume is 1982? 2. Let's just say I said 1990. What would be our T value? Well, 1980 is 0, so what would 1990 be? 10. So when it says f of 15, they're telling us that our T value is 15. So if our T value is 15, what year was that? 1995. 1995. And how did you come up with your 1995 in your head? Yeah, add 15 onto 1980. So take that initial year, add in what they're saying, and we come up with the year 1995. So let's do me a favor right now. You're going to go in here. I want you to plug this into Desmos, and then this is like our x. You don't have to put a t. You can put an x value. You can put x instead of a t. And then that's one equation. Your second equation should be x equals 15. So here's one equation. Here's your second. I want you to find out where do they intersect. So this means in the year 1995, because we're adding 15 onto the original starting year, we take this amount times 1,000. It states that within the question. We know that the profit was negative 945,000. Negative is the key. It means that this business in 1 year lost nearly. I did not go to school to be a drawer. I'm a math teacher. This is my function, and I want you to evaluate the type of multiplicity with each real root. That's a lot of technical terms. The type of multiplicity. So your answers are going to be like this: linear, quadratic, cubic. So what type of multiplicity? So you would say things like this. I think at negative 4 there is a multiplicity of. Okay, so can anybody tell me what do you believe the multiplicity is at negative 4? Anybody? Linear. Why? That's true. I believe at positive 4 the multiplicity is. Why? Bounces off. At 10, I believe the multiplicity is cubic. Why? Please turn to your partner and correctly identify on your paper what is the absolute maximum. Whispering to your partner, don't tell me go. Be careful. How do you correctly identify this? What's the absolute maximum? Tell your partner how you know that. Okay, next. What is the absolute minimum? There is no absolute maximum, there is no absolute minimum, but why? Because the arrows insinuate that as we go to the right, it will continue to go up. As we go to the left, it will continue to go down. To be absolute maximum or minimum, I'm talking loud, sorry for the video. To be absolute means there needs to be one and only one point that stands out as the highest or the lowest. To make this easier, I put little points that represent point A, B, C, and D. Which ones represent local maximums? Go.
A and C.
And which ones represent local minimums? So AC, local max. With your partner, I want you to identify the intervals that are positive on. So, if I could take a highlighter here, this is what I'm looking for. I'm looking for what's above and what's below. So, this portion represents where the function is positive. In terms of x values, it goes from -2 to -1. Why am I not putting brackets, but I'm using parentheses? Because at these particular points, it is neutral. Here again, it is positive. From 0 to 1 in terms of x values is positive. Again, right here, after leaving 2, it is positive. As it moves to the right, it remains positive. These are 3 of the intervals that represent where the function is positive. Now, where is it negative? This portion is negative. So as it moves to the far left, it's negative all the way up to the point of -2. Again, neutral at -2. From -1 to 0, it is negative, and from 1 to 2, it is negative. On this graph, I'm going to identify increasing and decreasing intervals. So here we go. It is increasing, turn point, decreasing, turn point, increase, turning point, decrease, turning point, increase. So this is the increasing from left to right, always using parentheses. Comes from the far left, and it continues to increase all the way up to an x value of -4.5. Then we have a turning point that starts to decrease. It decreases from -4.5 all the way down to -1. I'll make sure the pictures you have definitely have definite points that are easy to see, and you don't have to try to estimate anything. Okay, then it starts to increase after it leaves the point of x equals -1, and it's increasing from x equals -1 all the way up to 2.25. That's a turning point. It starts to decrease. Decreasing in this region, so from 2.25 all the way to an x value of 4, it is decreasing, has a turning point, and then as it moves to the right after 4, it is increasing. Turning to your partner, and this particular picture, how many examples of roots that have linear multiplicity? There are 3. 1, 2, 3. How many examples of roots that have quadratic? Just 1 here at 4. How many examples of roots that have cubic multiplicity? When they say to identify the multiplicities, we would say here's an example of quadratic. So 2, 0 is an example of quadratic multiplicity. And at 4, 0, it's an example of cubic. To describe the transformation, the order you describe them does not matter. We're going to be talking about, in this case, vertical, horizontal shifts. Also talking about how does the shape change. So is the shape going to be stretched or compressed? That means it's skinnier, is it wider? And then when we worked with quadratics, we used to say that it flips down. We will need to say things like it reflects across the x-axis in this case because our shape is different. We have a cubic function here. So the order we say these in does not matter. So this is going to represent a horizontal shift. So we're going to shift this function to the opposite, to the right. Caught myself. To the right 1 unit. So we have a horizontal shift to the right 1 unit. I may not be writing down all the words, but horizontal shift to the right 1 unit. We're describing from the parent function to this new function what's happening. This is going to be our vertical shift. Telling the truth, we are going to go up 5 units. So, horizontal shift to the right 1 unit, vertically shifting up 5 units. These are 2 separate things. Don't confuse them as one. The order you do this does not matter. A negative sign out front means that we are going to reflect across the x-axis. Reflect across the x-axis. It's just going to be flipped, okay? Reflect across the x-axis. And lastly, the shape, although still the same general shape will occur, it could get skinnier or it could get flatter. When this number is greater than 1, we say a stretch, or it's skinnier. Stretch by a factor of 3. So stretch and compress. Stretch is like skinnier, compress is like wider or flatter.
So those like 1, 2.
Yeah, we'll do one of those next. Yep, perfect. So let's do y equals 1/2 x plus 4 to the 4th minus 6. So if I had to compare these two, and I would say this is the parent function, this is my new function. So again, this is a little more obvious for us, but we're going to do opposite of what we think. So horizontally, I'm going to shift to the left 4. Vertically, I'm going to shift down 6. And then there's no negative sign, so I don't have to worry about saying reflects across the x-axis. But when this number is between 0 to 1, it's going to flatten out. So we're going to say compress by a factor of 1/2. And that means like to flatten out. Compress by